In this video, I will show you how to do hydraulic accumulator calculations. This is what hydraulic accumulators look like. There are several different types. Here are a couple cross sections of a bladder type accumulator and a piston type accumulator. You'll notice in the bladder type accumulator we'll pre-charge with nitrogen, and then as the oil fills it compresses the nitrogen in this bladder. The piston style accumulator is very similar. As the oil fills, it raises a piston which compresses this pre-charged nitrogen gas. So let's visualize how these piston style accumulators work. There's a nitrogen pre-charge. In this case, let's say it's 500 psi A. Notice I'm giving an absolute pressure here. And it's a 4-gallon accumulator. In other words, the total volume is 4 gallons. And this accumulator is placed in a hydraulic system where there's oil coming from a pump and going out to a circuit. If the flow in this circuit is blocked, we will see the oil begin to fill the accumulator, and the piston will begin to rise, and the nitrogen pressure will also increase. And it will continue to rise until the accumulator is full. Notice that the oil hasn't completely filled the accumulator because we still need to leave space for the compressed nitrogen. If oil is now allowed to flow to the circuit, oil from the accumulator as well as from the pump can flow to the circuit. So this accumulator is now providing more oil to the circuit than the pump could provide on its own. And the accumulator begins to discharge until it's completely empty. So here's an example. A 4-gallon accumulator has a 500 psi pre-charge pressure. Notice I'm giving it in absolute pressure. And it's placed in a hydraulic circuit containing a pressure relief valve that's set at 2000 psi, an absolute pressure. This problem asks us to determine the amount of oil that can be stored in that accumulator. So here's our empty accumulator, and the problem says it's 4 gallons, so the total volume is 4 gallons. And the problem also states that it is pre-charged with 500 psi of nitrogen. It also states that it's placed in a hydraulic circuit that contains a pressure relief valve that's set at 2000 psi. So we can think of this accumulator when it's completely full as having nitrogen that's been compressed to 2000 psi. The problem asks us to determine the amount of oil that can be stored in this accumulator. So it's this volume of oil that we're trying to find. And we can't determine that directly, but we can easily determine this volume of nitrogen. We can treat the nitrogen as an ideal gas. The ideal gas equation, PV equals mRT, we can rearrange that. PV divided by MT equals R, and R is the gas constant. So R is a constant. PV divided by MT equals a constant. P1 V1 over MT is going to be the same as P2 V2 over MT. And if we make the assumption that no nitrogen leaks out, the mass is the same in each case, and if this accumulator fills slow enough that the temperature stays the same, it doesn't heat up or cool down, then those will cancel out of the equation, and we'll be left with this equation showing that the pressure and volume from state 1 to state 2 are proportional. Now I'd like to highlight the fact that in this problem we provided the absolute pressure. It's important to know that this ideal gas equation requires absolute pressures. So it's a pretty easy calculation. We can solve for volume 2 as 1 gallon. In other words, as the pressure increased fourfold, the volume decreased to 1/4. So we've now found this volume of nitrogen. But that's really not what we were looking for. We were looking for the volume of oil that this accumulator can hold. Well, that's a simple subtraction problem. The total volume was 4 gallons, and 1 gallon of that is now in compressed nitrogen, which leaves 3 gallons left over for the oil. So this 4-gallon accumulator has the capacity to hold 3 gallons of hydraulic oil. Let's do another example. A 6-gallon accumulator has a 300 psi pre-charge. Now this is a little more realistic because the pressures are now given in gauge pressures. And that's typically how we measure pressure in hydraulic system, is with pressure gauges. And this hydraulic circuit contains a pressure relief valve set at 1500 psi. And it asks us to determine the amount of oil that can be stored in this accumulator. Well, here's our empty accumulator. The 6 gallons is the total volume of this accumulator. It has a 300 psi pre-charge. It's a nitrogen precharge, so our P1 is 300 psi. It's placed in a circuit that contains a relief valve set at 1500 psi, so when this accumulator is completely full, the nitrogen will be pressurized to 1500 psi. The question asks us to determine the amount of oil that can be stored in the accumulator, this volume here. We can't calculate that directly, but we can calculate the volume of the compressed nitrogen using the ideal gas law. And this equation, remember, makes the assumption that no nitrogen leaks out and that it fills slow enough that the temperature stays the same. So this is the isothermal assumption. Now notice these pressures are more realistic because they're given in gauge pressures. This ideal gas equation requires pressures to be given as absolutes. So notice we've added 14.7 to each of those pressures. And that will allow us to calculate the volume of the compressed nitrogen. In this case, 1.25 gallons. That's this volume here. The compressed nitrogen, 1.25 gallons. But that's really not what we were looking for. We were looking for the oil volume that this accumulator could hold. Well, that's a simple subtraction problem. 6 gallons total, 1.25 gallons taken up by the compressed nitrogen, which leaves 4.75 gallons for the oil. So that's the answer we were looking for. So this 6-gallon accumulator will hold 4.75 gallons of hydraulic oil. What if the accumulator fills so quickly that the nitrogen temperature changes as it is compressed? Here's a similar example. It's a 6-gallon accumulator, has a 300 psi precharge of nitrogen, and it's placed in the hydraulic circuit that contains a pressure relief valve set at 1500 psi. But as it fills, the nitrogen temperature changes from 70 Fahrenheit to 110 degrees Fahrenheit, and we need to determine the oil capacity. Well, here's the accumulator. The 6 gallons is the volume of this nitrogen precharge, which is 300 psi. And the relief valve is set at 1500 psi, so that when that's full of oil, the nitrogen has compressed to 1500 psi. Now, as it fills, it does it so quickly that the nitrogen hasn't had a chance to cool off as it compresses, so the temperature changes from 70 Fahrenheit to 110. The precharge is 70 degrees Fahrenheit room temperature, and the compressed is 110 degrees Fahrenheit. We're looking for this volume of oil that would be in the accumulator, and we can't calculate that directly, but we can calculate this volume of the compressed nitrogen using this ideal gas law. It's important to know that both temperatures and pressures have to be given in absolute numbers. So in this case, notice I've put the pressures in absolute numbers. I've added the 14.7, and I've also given the temperatures in absolute numbers. I've added the 460 to convert it to degree Rankine. And we could do some algebra and find that volume 2 is 1.34 gallons. That's this volume here of the compressed nitrogen. So if I want to find the volume of oil, I just do a simple subtraction. 6 gallons subtract 1.34 gallons would give me 4.66 gallons of oil. Here's another circumstance you might encounter when doing accumulator calculations. What if the accumulator does not completely discharge? Here's an example I will use to help you understand how to approach these types of problems. It's very similar to the previous examples. A 6-gallon accumulator has a 300 psi precharge, is placed in a hydraulic circuit containing a pressure relief valve set at 1500 psi. But notice this circuit is designed so that the accumulator will never fully discharge. It will fluctuate between 1500 psi and 700 psi. And that's probably due to something in the hydraulic circuit where anything less than 700 psi just wouldn't be useful. Let's determine the oil capacity of this accumulator. Well, first of all, let's recognize that it's 300 psi precharge. So there's our empty accumulator that has that 300 psi nitrogen precharge. We'll also recognize that the relief valve is set at 1500 psi. So as it fills, it compresses the nitrogen until it's 1500 psi. We want to find the amount of oil in the accumulator at this stage. We can't do that directly, but we can determine the volume of the compressed nitrogen using the ideal gas law. And we're assuming that the temperature stays constant here, that it's isothermal compression. And again, notice that we're adding the 14.7 so that the pressures are in absolute numbers, and we can solve for that volume 2, 1.25 gallons, which is the volume of this compressed nitrogen. And using the simple subtraction, we can find out that the volume of oil is 4.75 gallons. But notice in the problem statement it says that the circuit is designed so that the accumulator will never fully discharge, and that it will fluctuate between 1500 psi and 700 psi. So when the accumulator has discharged such that the pressure in the nitrogen is 700 psi, we're going to consider that no longer usable. So we're going to want to find the volume of oil that's still in the accumulator here that's really no longer usable because the pressure is so low. But we can't calculate that directly. We're going to have to find the volume of the compressed nitrogen using the ideal gas law. We can again plug in our absolute pressures and find that volume 3 is 2.64 gallons. So this volume of compressed nitrogen is 2.64 gallons. And again, we can do our simple subtraction. 6 gallon total minus 2.64 gallons of compressed nitrogen will result in 3.36 gallons of oil left in that accumulator that are really not usable. So this now becomes our usable capacity of the accumulator. 4.75 gallons of oil subtract 3.36 gallons of oil would mean that there's really only 1.39 gallons of usable oil in that accumulator, simply because the pre-charge pressure was low, 300 psi, too low for anything useful in our hydraulic circuit. So that this accumulator really is only fluctuating between the 1500 psi and the 700 psi, giving up 1.39 gallons of oil.